Modern physics has no fundamental understanding of the arrow of time, but in a new theory called quantum atom theory, the continuous flow of time is formed by the emission and absorption of electromagnetic radiation, or light. Light will radiate out from its radius in all directions, forming light spheres of electromagnetic radiation. Only if the light waves come in contact with an object will they form new photons of energy that will have a unique position in space and time. This is a continuous process forming the arrow of time and the geometry of space-time. If the light does not come in contact with an object, it will only have the momentum of its own frequency and wavelength. The probabilistic nature of light is forming a sea of electromagnetic radiation, creating a blank canvas for the observer that he or she can participate in. This is what Socrates called a sea of beauty. Put in a more scientific way, Heisenberg's uncertainty principle of quantum mechanics is the same uncertainty the observer will have with any future event. We live in a dynamically evolving universe of continuous change. Because waves by their nature have to move, therefore we cannot achieve absolute zero, and all atoms radiate light or electromagnetic radiation continuously. Even the individual atoms of the observer are radiating electromagnetic radiation, forming their own space-time geometry in unison relative to their position and momentum. It is because we can choose when and where to collapse a wave function that we have free will to create our own future. The observer is at the center of their own created symmetry or reference frame and can look back in time through light years of space at the beauty of the stars. The position of the observer within the universe makes no difference. Whatever planet or galaxy he observes from, he will be able to look back in time in all directions from the center of his own reference frame. In quantum atom theory there is no universal time, because the universe is made up of an infinite number of reference frames, or space-times, that will have their own local space-time geometry relative to their position and momentum. We have time dilation for an object accelerating towards the speed of light, and gravitational time dilation around objects of great mass, because the greater the momentum, the shorter the wavelength, and the higher the frequency. Therefore the greater the energy or mass of an object, and the higher the frequency gets, the Planck constant is then multiplied by the larger amount, and the duration of a clock cycle will increase. Therefore it will be measured to run more slowly. Because of this we have the second law of thermodynamics, and heat flows from higher temperature to lower temperature, and never the other way round. In quantum atom theory, at the quantum level of the atoms, the moment of now is created by a single photon-electron coupling, creating a wave function of future possibilities. On the level of everyday objects, the observer will see the multiplication of photon-electron couplings, creating a temporary image of the universe, moment by moment. The observer is always in the moment of now, collapsing the waves of light into new photons of energy that will only be relative to the observer's position and momentum. In this theory it is more than beauty that is in the eye of the beholder, but part of creation itself. This is very difficult to visualize, but in this oil painting of a geisha girl walking through sunlight, the wave-particle duality of the light will collapse as she walks through the rays of light. She will collapse the wave function into moments of time and space, creating her own space-time. Because each atom is creating its own space-time at the same rate that light moves, the speed of light between the atoms will always be a universal constant, independent of the motion of the source. This can also explain why light is so beautiful when it strikes an object. It is because we are looking at a moment of pure creation of time and space. The only way to see this happen directly with light is in the two-slit experiment. When the wave function reaches the screen with the two slits, the photon will react with the electrons of the screen. This will collapse the wave-particle duality of the light, creating new quantum particles in space and new moments in time. The part of the wave that does not come in contact with the screen will expand in all possible routes, going through both slits as two light spheres of quantized wavefronts. Constructive and destructive interference between the waves will cause them to superimpose or cancel each other out. When this wave-particle function comes in contact with the screen, it will collapse, creating moments of time and quantum particles in the shape of an interference pattern. When the observer turns on a detector to determine which slit a photon passes through, the interference pattern collapses. This is because to observe a photon, we have to create a photon-electron coupling, collapsing each wavefront into a new quantum particle that will have its own position in space and time. If we turn the detector off, we remove the photon-electron coupling, and in time the interference pattern will reform. Just like in Newton's first law of motion, the interference pattern will continue to maintain its state, unless acted upon by an external force. We have quantum entanglement because the polarization will be set at the creation of each expanding wavefront. The wavefront will expand in the form of a light sphere, and the polarization will remain the same for the entire surface of the light sphere, no matter how large it becomes. We have Einstein's curvature of space-time because of the physical shape of the quantum wave-particle function. This is why we have pi in the equation representing the shape of the wave function in three-dimensional space-time. We also have pi in the equation for Heisenberg's Uncertainty Principle. This is why pi is an irrational number and keeps on going forever, just like time, never forming a regular pattern, with all the properties of a random number, just like probability, except that each of its digits are known. There is always the same amount of even and odd numbers in the continuous sequence of pi. Just as if you continuously tossed a coin, you would create a sequence of numbers with the same amount of odd and even numbers, or heads and tails. Light is always radiating out from its radius a square of probability. This is the same square of probability you will have with any future event. If you toss up a coin, you will mathematically create a square of probability. Because all objects, even people, are radiating light or electromagnetic radiation continuously, we are all creating our own future probability. Just like the coin, we fulfill this as the aging process and as the continuous flow of time. Quantum atom theory can explain the paradoxes of quantum physics, and can give us a reason for the arrow of time that we see and feel in our everyday lives.